This is video 3 for the ANCOVA assignment for Psych 642. In this video, I'm going to be picking up right where I left off at the end of video number 2 and start by opening all of my script files. So I have two different files for this. One that has the different packages that'll be used, and the other that has the script that I'll run to complete the assignment. So the first thing I'm going to do is just load all of the packages. And you can see that here on lines 14 through 17, I've also created a function to get the effect size of the different planned contrast comparisons. I'll talk more about that whenever we go through the code, but I'll be running the R contrast function that you see specified here with the formula for R, which is the square root of t squared divided by t squared plus the degrees of freedom. So I'll talk a little bit more about that whenever we get to that point in the assignment, but this is where I've put the code for the creation of that function, which was discussed in the textbook chapter. Okay, so now that all of the packages should be open and running, I'm going to go ahead and clear my console here so that it doesn't look like such a mess when we start getting some of the output. But I'm going to switch back over to the other script file, which has the script that I'll be running for the assignment. So the first thing that I have to do is attach the data set so that it can be used for the analysis. So as you'll remember from the last video, I imported the data set, which you can see over here on the right side of the screen, the SO depression data set, but I need to attach that in order to be able to use it. So I'm going to go ahead and do that using the attach function. Okay, so now that the data set's attached, I can start to use it, manipulate it, run tests, all that stuff. The first thing that I have to do, though, since I'm looking at the differences between different groups, is I have to use the factor function to change the format of the variable SO, which represents sexual orientation, from numeric to categorical. Because if you remember from whenever we were looking at the data set before, which you can see here, sexual orientation is indicated by the numbers 1, 2, and 3. So I need to change that to a categorical variable using the factor function, which you can see here. I'm setting it the same variable, the SO variable in the SO depression data set will be factored using 3 different levels, which you can see is specified here with the labels heterosexual corresponding to label 1, homosexual corresponding to label 2, and bisexual corresponding to label 3. So I will go ahead and run that and factor it. And since that's been done, you can see that it's been done correctly by looking at the variable over here on the right side where it says factor with 3 levels and then gives the different levels. And then you can also go back and look at the data set and make sure that it's been correctly labeled with your different categorical labels. And in this instance, you can tell that it has worked properly. All right, so the next thing, once the factor's been set up to define your different groups, is we want to just kind of take a look at the data and run some of the assumptions. As I talked about in the rationale, I do plan to use an ANCOVA for this analysis. So I'll be specifically looking at the data and doing looking for things and doing assumption tests specifically related to things that are needed for the ANCOVA test. So the first thing I'm going to do is just get some general descriptive statistics on the data that I have, and I'm going to use the by function. Doing this separates out the descriptive statistics for each variable based on the groups of sexual orientation. So rather than just giving like a total average or a total mean of depression scores, it'll give the means of each of the different sexual orientation groups. So the mean depression scores for heterosexual individuals, homosexual individuals, and bisexual individuals. And the same for family income. It'll break it down in that way, which you can see is specified here. The by function, your outcome variable of depression, the grouping variable, and then the actual function that we're trying to run, which is descriptive statistics. So I'll go ahead and run that. You can see the output popped up down here, which we'll look at the specific output a little bit more in detail in the next video. We'll go through the output all at once and discuss how that relates to the write-up of the results summary. But you can see, as I mentioned before, that it gives a range of descriptive statistics, including the median, the mean, the standard error, as well as the standard deviation and some other descriptive statistics of each of those groups. And just kind of glancing at it, it looks like heterosexual individuals have lower mean depression scores than homosexual or bisexual individuals, and it also looks like bisexual individuals do have a higher mean than the homosexual individuals. But that's what we're going to do the test for, to find out if that difference actually exists. And then you can also look at the means for family income. It does not really seem to be a giant difference here, so hopefully we'll be okay on some of the assumptions that we're about to test. Alright, so the first assumption that I'm going to test is test each of the continuous variables for normality. So we're going to look at both the depression scores and the family income and test to make sure that the data meets the assumptions for normality that we discussed in one of the previous videos that's required to run the ANCOVA. So once again, I'm going to use the by function because since we're looking at 3 different groups, we want to make sure that the data is normally distributed within each of the groups. So once again, the by function will separate the results of the specific test you're running, which in this case we're doing the Shapiro test. It'll separate the results of the Shapiro test for the depression scores based on sexual orientation, and then the same for family income. So I'm going to go ahead and run that. And just a brief glance at the output down here shows that the normality tests for the different groups on depression scores, none of them were significant. So we can take that to mean that these distributions are not significantly different from what a normal distribution would be, which is what we're hoping for in order to be able to run this test. And then for family income, we can also see that none of the tests for any of the groups were significant, which once again is what we're looking for, because it shows that the distributions do not differ significantly from a normal distribution. So our assumption of normality for each of these groups on these two variables is met. So we can move forward with running more assumptions and hopefully get to running the test. So the next assumption that we're going to test is the homogeneity of variance. We'll do this using the Levene test. So this tests whether the variance in the levels of depression, or just your outcome variable in general, varies across the groups. So in this instance, that's sexual orientation. So in each group of sexual orientation, we want the variance in our scores to be relatively similar, which we discussed, or which I discussed previously when talking about the assumptions. So that is what this Levene test will do. So I'm going to use the Levene test function to accomplish this. You can see that our outcome score that we're going to be testing is depression, and then sexual orientation is the grouping variable. So I'm going to run that. And once again, you can see that our p-value is greater than 0.05. So we do not, our variance between the different groups is not significant, which means that this assumption has been met as well. So now that we have tested those assumptions, which are some of the basic assumptions of parametric tests, including the ANCOVA family, which includes ANCOVA, I'm going to test some specific, or one specific assumption that is only relevant or to ANCOVA, or that is different about ANCOVA from ANOVA, and that is testing for independence of the covariate from the independent variable. So we want to make sure that the covariate is roughly the same between groups. We want to make sure that they're not related there, which I previously discussed in the other video, so I'm not going to go into a whole lot of extra detail here, but I'm going to do this by running an ANOVA using the covariate as the outcome variable and the independent variable of sexual orientation as the independent variable from the only data set that we're going to be using, SO depression. And then I'm going to use the summary function to provide the information that's now been specified for that model into the object of IND test. So doing that gives the results of this ANOVA, and we can see that it is very non-significant, which means that we have met this assumption, and family income is relatively level or equal between the three different groups of sexual orientation. Alright, so the next thing I'll be doing is actually setting up my ANCOVA model, and this will be where I pick up in the next video. So in this video, we've gotten started, we've tested the assumptions, set the factor, loaded the different packages, and kind of got everything set up to build this ANCOVA model. And in the next video, we'll actually create and execute this model to test our hypotheses.